In this video, we will see an example on Kirchhoff's laws in the frequency domain. Question: find V of t and I of t in the circuit shown in figure. We have to find the value of this current and this voltage, which is the voltage across this inductor, and this is a RL series circuit. So solution: first of all, let's copy this circuit. Now we will write what is given. So the value of voltage is given, supply voltage Vs is equal to 20 sin 10t plus 30 degree volt. It is given in time domain format. It is in time domain format. So what we will do, we will compare this with standard equation, that is V is equal to Vm cos omega t plus phi. This is the standard equation. So here we can see, here it is sine and here it is cos. So first we will convert this sine to cos. So let's go to the basics. Here on this horizontal axis, this is plus cos omega t, and here this is minus cos omega t. On this vertical axis, this is plus sin omega t, and here this is minus sin omega t, minus sin omega t. Now here we have to convert sine to cosine. So we have to convert this sine to cosine. So we are moving from here to here in this direction. So we have to add plus 90 degree to it. So this means we actually want to move from here to here. So here we have to subtract 90 degree. That means sin omega t is equal to cos omega t minus 90 degree. Cos omega t minus 90 degree. So here in place of this sine, if we substitute cos omega t and then minus 90 degree, so it will become cosine. So therefore Vs is equal to 20 as it is. Then in place of this sine we can substitute cos this 10t plus 30 degree as it is, 10t plus 30 degree as it is. Just we have to subtract 90 degree, and since it is a voltage, so its unit will be volts. So now this will be Vs is equal to 20 cos 10t, and this will be minus 60 degree volt. So this is the value of Vs in time domain, and in frequency domain it will be Vs is equal to 20 at an angle minus 60 degree. Here the value of omega is equal to 10 radian per second. Now what we have to find? We have to find I of t. So in frequency domain, I is equal to V upon Z. So here the value of V is Vs, which is 20 at an angle minus 60 degree divided by Z. Now here Z is equal to, here we can see Z is equal to R plus Jx, and we know that X is equal to, X is the reactance, which is equal to XL minus XC. So here XC is absent, that is capacitive reactance is absent here. So it will be R plus JXL only. So therefore Z is equal to R plus JXL. So R plus JXL. So first we have to find the value of this XL. So XL is equal to omega L. the value of omega is 10 and the value of L, that is inductance, it is 0.2 Henry. So 0.2. So this will be 10 multiplied with 0.2. So it is 2, and since it is inductive reactance, so its unit will be ohm. So let's substitute it here. So I is equal to 20 at an angle minus 60 degree divided by resistance. The value of resistance is, here we can see it is 4 ohm. So 4 plus j XL, the value of XL is 2. Now here the numerator is in polar form and the denominator is in rectangular form, and we know that multiplication and division are better performed in polar form. So here we have to convert this into its equivalent polar form. So 4 plus j2 is equal to under root of x square plus y square at an angle tan inverse of y by x. So here this 4 represents x and this 2 represents y. So this should be under root of 4 square plus 2 square at an angle tan inverse of y by x. The value of y is 2 and the value of x is 4. So if we solve this, so it will be under root of 4 square plus 2 square. So it is 4.47 at an angle. Now tan inverse of 2 by 4. So it is 26.56 degree. Now we can substitute it here. So let's copy this directly. And here we can substitute 20 at an angle minus 60 degree as it is. In the denominator, in place of this 4 plus j2, we can substitute this value 4.47 at an angle 26.56 degree. So this will be 20 divided by 4.47. 20 divided by 4.47. It is 4.47 only. So same value we got 4.47 at an angle 60 minus 26.56 degree. So therefore I is equal to 4.47 at an angle, this will be minus 60 minus 26.56. So it is minus 86.56 minus 86.56 degree, and since it is current, so its unit will be ampere. So this is the value of current in frequency domain. In time domain, it will be I of t is equal to this value 4. First we will write the formula Im cos omega t plus phi. So value of Im is 4.47 cos the value of omega. The value of omega here we can see it is 10 radian per second. So 10 radian per second, 10t plus the value of phi. The value of phi here is minus 86.56 degree. and since it is current, so its unit will be ampere. So this is the value of current. Now we also have to find the value of voltage across the inductor. To find the voltage across inductor, we know that the V and I relation for inductor in frequency domain is given by V is equal to j omega L I. So we have to find the value of voltage. So here this J is 1 at an angle 90 degree. J means 1 at an angle 90 degree. And the value of omega is 10 radian per second. So it is 10 into the value of inductance. The value of inductance is 0.2 Henry. So 0.2 multiplied with current I. Now here the value of current I will be this value 4.47 at an angle minus 86.56 degree. So let's simplify this. So it will be 1 into 10 into 1 into 10 into 0.2 into 4.47. So this will be 8.94 at an angle 90 degree plus, so here we have to add with minus 86.56 degree. So therefore V is equal to 8.94 at an angle 90 plus in bracket minus 86.56. So it is 3.44. Since it is a voltage, so its unit will be volts. So this is in frequency domain format. We have to convert this into time domain. So this will be V of t is equal to Vm cos omega t plus phi. So therefore V of t is equal to, the value of Vm is 8.94 cos omega t. The value of omega is 10. So 10t plus the value of phi is 3.44, and since it is a voltage, so its unit will be volts. So this is the value of voltage in time domain format. Here we can see the voltage is in sine form. So let's convert both the answer in sinusoid form. So here this is the answer for current. So let's copy this, and this is voltage. So first we will convert this current. So this current in sinusoid or sine form will be I of t is equal to 4.47 sine 10t minus 86.56 degree. Now here we have to convert cos to sine. So again here we can see from this graph we have to convert this cos to sine. So that means we are going from here to here like this. So we have to add 90 degree. So the formula will be something like this: sine omega t plus 90 degree is equal to cos omega t. So here we have to add 90 degree to it. So this will be I of t is equal to 4.47 sine 10t, and this will be 86.56 minus 86.56 plus 90 degree. So it is 3.44 plus 3.44, and since it is current, so its unit will be ampere. So this is the final answer for current. And for voltage, this will be, again let's copy this. Let's copy this. Now here we will convert this into sine form. So V of t is equal to 8.94 sine 10t plus 3.44 plus 90 degree volts. So therefore V of t is equal to 8.94 sine 10t, and this will be plus 93.44, and since it is a voltage, so its unit will be volts. So this is the final answer in sine form. So this is how we can find current and voltage in sine form. Don't forget to like, share and subscribe to this channel, and thanks for watching.